In today's video, we're going to be taking a look at another brand new low-cost IP KVM device, and this time it's the GL.iNet Comet. But first, I'd like to say a massive thank you to GL.iNet for sending me this to take a look at, and just so that I'm completely upfront, GL.iNet have sent me this free of charge to take a look at, but they haven't told me anything to say, no money changed hands, and they aren't seeing this video before it goes live, so I'll be giving my own thoughts and opinions about this product. But just so that I'm completely transparent, I'll enable the includes paid promotion thing on this video. So first up, what is it? Well, for those of you who don't know, this is an IP KVM device, which stands for Keyboard, Video and Mouse, and it essentially lets you access a connected computer remotely over a network, independent of its operating system. It's a similar idea to the management controller built into many high-end servers, except this can be used with anything that can output video over HDMI and accept a USB keyboard and mouse. It also offers virtual media support where it can act as either a USB optical drive or a USB flash drive, allowing you to transfer files or even boot the machine into an ISO file to perform maintenance or even remotely reinstall the operating system. It's a very similar idea and almost a direct competitor to the Jet KVM I took a look at a few months ago. So throughout the video I'll pop in and compare the two since they're around the same price point, and there's some things I prefer about the GL.iNet and other things I prefer about the Jet KVM. So first up, let's take a look at the hardware. It's a nice little metal box, and then on this side here we have an Ethernet port to connect to the network, and then a USB-C port to power the device. Around the side here we then have a USB-A port for connecting external accessories, which we'll take a look at shortly, an HDMI port to send video into the device, and then a USB-C port, and this time this one will carry the USB keyboard and mouse data. Then finally we have a status LED on the top, and on this side here we have a reset button. So it's a pretty simple device, but the layout all seems pretty sensible. And I do like how compared to the Jet KVM, they use a full-size HDMI connector and have separate connectors for power and data with USB-C. As you can see on the Jet KVM, they ended up using a mini HDMI connector, which is a shame since it isn't particularly common, and I feel like I need to therefore store the cable alongside the KVM in case I need it. Whereas with the Comet, I can happily use any HDMI cable, I can just store the device on its own and use any regular HDMI cable with it, which is a lot easier. Then for power, I do prefer the way the Comet does it, but neither of these devices really has the perfect solution. On the Jet KVM, we have a single USB-C connector which both powers the KVM and allows it to control the connected computer. The benefit of this is that you don't need as many cables, but the downside is that if the connected computer powers down or resets the power to its USB ports while it's rebooting, you'll end up causing the KVM to also reboot, which can be a massive pain if you need to do something like enter the BIOS, since the KVM likely won't boot quick enough to let you press the relevant keys. Jet KVM's solution to this is to include this power splitter cable. This allows you to connect a separate power source while still connecting the USB data to the computer. This, however, is another sort of somewhat uncommon cable, and therefore I always feel like I need to keep this alongside the KVM in case I need it. So instead on the Comet, they've instead opted to offer a pair of separate USB-C connectors. One allows you to plug in a persistent USB power source, and then you can connect the data port to the computer you want to control. The downside here though is that you can't power it from just the data port. You need to keep the power connection connected as well. Now of course if you have a computer that has persistent USB power, you can just plug both of these into the same computer, but it would have been nice if you could have powered it through the data port and then only have a single cable like you can do on the Jet KVM. Then on the Jet KVM, you do have the screen, which is nice since it lets you see its IP address, but you don't have that on the Comet, so you'd either need to use the MDNS hostname or look up the IP address from your DHCP server. So when it comes down to it, it really depends on what you prefer. I think I do prefer the Comet since I value more having the sort of standardised cables and connections, and most of the time I'd be using this with computers that would need a separate external power source, but if you prefer having a single USB connection or you want something like the screen, then you may want to go with the Jet KVM. So, as I mentioned, the Comet has this USB-A port for connecting external accessories. Right now, they only seem to have this ATX Power Control Board, but of course they could expand this in the future. So what you can do with this board is you can connect it to the front panel I/O connections on your motherboard, such as your power and reset buttons, and then you can control those remotely from within the web interface. As you can see on the board here, we have these two sets of pins. One would go off to your motherboard, and then the other would connect to the front panel on your case, meaning that this doesn't completely replace your front panel buttons, it just sits in the middle. Then on the other side you have a USB-C connector, which you'd run over with a cable and connect to the main KVM unit. Now there's one thing to bear in mind here, and I'd like to thank Lawrence Systems for mentioning it in his video, is that the way they're controlling the power and reset switches means that these connections are actually polarity sensitive. So whereas when you're connecting a physical button to your motherboard, the polarity just doesn't matter, with this it does. Now of course your motherboard might not even have the polarity labelled, So in that case, you simply need to try it one way, and if it doesn't work, flip it around. Just something to bear in mind because it's not something you'd normally expect with front panel buttons. Then to connect it to your motherboard, they include this little breakout cable here. One end will go off to the board, and then the other connections are all labelled that would go off to your motherboard. Then what I really like is they include a pair of brackets that would allow you to mount this into a free expansion slot on your case. They both include a full height and a half height bracket, so all you would do is screw the bracket onto the board and then mount it into a free slot of your case. The Jet KVM does have basically the same thing, although I don't have one here to show you. The only difference is instead of using USB to connect it like they do on the GL.iNet, they use an RJ11 serial port. So now let's test this out and take a look at the software. So here's my test setup where I have it connected to this mini PC over HDMI and USB for the keyboard and mouse control. I then connected the Comet to the network using this Ethernet cable, and I've also connected it to a permanent USB power source. Then over on the computer, we can either find its IP address through my DHCP server, or as long as your network allows multicast DNS and you've only got one of these devices connected, we can simply go to GL.KVM.local and that'll pull it up. We then get a login screen. The first time you do this, you'll be asked to set a password, which is nice. It's much better than it coming with a default password that people will never change, so it's good to have it force you to change a password. I've already done that, so we can just simply log in, like that. And as you can see, here we are logged in, and we can see the display of the connected computer. We can then come in here, we can click around, we can drag windows around and all that sort of stuff, and it all works. Then along the top, we can go to settings, and under here we can pick things like the EDID, which defines the type of monitor it will emulate. Different EDIDs will allow different resolutions. Right now I have it set to 1080p, but I can go all the way up to 4K 30 if we wanted to. Then we have this quality setting that essentially lets you pick how much compression is applied to the video. I've set this to ultra high since I'm on the local network, but if you're accessing this over a slow internet connection, you may want to decrease this. We then have these options here to define which devices can be passed over from the remote computer, as well as this option here that lets you enable an on-screen keyboard. And this is particularly useful if you want to set any key presses that would otherwise be grabbed by your browser or computer's operating system. So things like function key presses, certain things like Control-Alt-Delete, that sort of thing, this virtual keyboard is really useful for. Then finally on top of that, we have an option here to let you pick the language. Then also another option to choose between light and dark mode. And then finally we have a reset option here. Just bear in mind that this reset option means to factory reset the device. If all you want to do is reboot it, that's up here in the top right. Then next up on the Toolbox tab, we have a few other options. For example, we have options to send to specific key presses, such as Control-Alt-Delete. We have an option here for Wake on LAN that lets you add devices by their MAC address and then remotely control them using Wake on LAN. We have an Access Terminal option here that opens up a terminal on the underlying Linux operating system on the Comet, which is particularly useful. We'll take a look at this later in the video. And then finally on this tab, we have this option here for Clipboard, which is a feature that I always like to see on this sort of thing that allows you to paste text into the connected computer by emulating a keyboard. We can click into a text field like this notepad window over here, enter some text in here, this is a test, and then click Paste to Remote Device. And as you can see, the text has been entered into the computer. This is really useful for things like pasting in passwords or long terminal commands. The only missing feature here is that this appears to be hard-coded to use an English US key map. So if the connected computer is expecting something different, some special characters might get mixed up. This is in contrast to the PiKVM, which lets you pick a key map what to use when pasting. But stay tuned for later in this video because that PiKVM option might actually be a solution on this device as well. Next up we have this option here for accessories, which refers to things like the ATX Control Board. Currently I have it connected, so if we go into here we can see we have options to both trigger the power and reset buttons, and for the power button it gives you both options of a long press and a short press, so you can either initiate a safe shutdown or force power off a machine. Then the final feature we'll take a look at is Virtual Media, which allows you to mount ISO files or transfer files to the connected computer. So if we click onto this here, we can see we have a total storage space of 5.7 gigabytes of storage, and then there's an option to upload files. Now, this isn't a huge amount of space, especially with some Windows installers potentially getting close to that, if not larger, and even nowadays Ubuntu Desktop is around 5.9 gigabytes, but it should be fine for most of the sort of Linux ISOs you'd install on a server. And then in here, we can pick to upload an ISO, so we can go into here, pick one there, and start uploading. And as you can see, it's uploading. Now, it's not particularly fast. Right now, it's uploading at round about 12 megabytes a second. But equally, right now, I'm actually going off script because I previously tested this with a previous software version, and it only uploaded at about 6 megabytes a second. So it does seem like they've potentially done something in this recent software update that has improved that a bit. 12 megabytes a second is at least better than it was before. It's not fast, as you can see. This is maybe a 600 meg ISO, and we're having to wait a good while for it to upload. It's not as bad as it was before, so at least they have done some sort of improvement, but it's not a particularly fast experience. So this is a bit of a shame. At least you'll have the feature to get you out of trouble, but if I had the option of plugging a USB drive directly into the connected computer, I'd absolutely end up doing that instead. Reading from it, however, is a bit faster, around about 25 megabytes a second or so, so at least once you get an ISO onto it, it's not too painful to actually boot from it and install an OS. So with this, another option you might want to consider is using something like netboot.xyz. This is a very small ISO you can boot from, and this will then let you boot various ISOs directly from the internet. And since this would then be using the client computer's own network connection, it should be a lot faster than uploading an ISO onto the KVM and then booting that. So we'll take a look at booting an ISO in a second, but another feature that I really like that we can do with this KVM is mount the KVM as if it's a USB flash drive. So we can go to Virtual Media, Mount to Remote, and click File Sharing. It will then pop up on the connected computer as a removable disk, and we can then copy files in or out. So for example, I have a test file on the desktop here, like that, drag that into the KVM. We can then go Virtual Media, Stop Sharing, and then that test file is now available to download from within the KVM's web interface. So this could be really, really useful if you're either wanting to collect files from connected computers or to transfer things like software and scripts onto them. So this is a really nice feature to have, however it's just a shame that it's a little bit slow and it has relatively limited storage. On the other hand, with the Jet KVM, it has the same ability to mount ISOs, however it also has the ability to mount images directly from a remote URL or by streaming it through your browser without uploading it first, so that's nice. However, it doesn't currently have the ability to mount it as a removable disk, which is something that I could really see myself using on the Comet. Now, since the storage limitations are likely down to the hardware of this, especially around the overall storage space you have available, what would also be a nice future software update would be if they allowed you to connect a USB flash drive to the USB-A port and use that for storage instead. And to be fair, that might be something you could even bodge by messing with the underlying Linux system, but it's not something I've tried myself. So now, let's take a look at how we can use this to boot the machine from an ISO file. So for this, we'll use Linux Mint since it's already on the KVM. So we'll go to Virtual Media, Mount to Remote, Image Mounting. We'll then pick the ISO we want to mount, press Mount Image, and that will now pop up on Windows as a connected CD drive. So now let's boot into it. So what we'll do is we will click Start, click Reboot, hope this thing doesn't update because I don't want to have to deal with that, and then wait for the computer to reboot. Get these pop-ups there. And then once it reboots, I'm just going to try and press delete repeatedly and get into the BIOS and boot from it. So now it seems I've rebooted, so I'm just going to start hitting delete. You may also want to use the on-screen keyboard for this, and we're in the BIOS. So as you can see, we're able to use the BIOS through this, which is one of the main reasons to use a KVM such as this. We can flick through here, all absolutely fine, all works as you'd expect, and then we should be able to then tell it to boot from the presented ISO from the KVM. So on the machine's boot manager, it presents itself as a Linux file CD gadget. That's just how it works. So if we pick that, we will then start to boot from that Linux Mint ISO. There we go, start Linux Mint, hit that, and we can watch the machine boot up. And as you can see, we're now booted into Linux Mint from the KVM's virtual optical drive, and it all works fine. I think with some very early firmware versions of this, people were having issues trying to get it to work with Linux desktop clients for some reason. They couldn't, if the connected computer was running a Linux desktop environment, there were just issues trying to get video out of it. But I've always been running the newer software versions, I've had no issues. It seems to work absolutely fine with Linux, both as a desktop operating system, and then if we switch to a purely command line, it all works completely fine under that as well. So yeah, it works fine with Linux. Then in terms of other functionality, we have the App Center, which gives access to the built-in Tailscale support, which is really good if you want that for remote access. They also have a cloud feature, which you can see up here, although this requires a desktop app to set up for some weird reason, and it's not something I'm particularly interested in, so I haven't tried it. GL.iNet are a pretty large established company, so I don't necessarily not trust it, but I think for something like this that gives complete out-of-band access to a machine, the security is so crucial that I'd always want to connect them over a trusted VPN connection, unless there was some very specific emergency that required me to use the cloud connection. And at least Tailscale does kind of give you that well-trusted built-in VPN for situations where you don't necessarily have a VPN connection to a remote site. So I interrupt this video to bring you a discovery I've just made while editing this video about the cloud connectivity, and I'm not a huge fan of it. So to set up the cloud connectivity, the way you need to do it is you would download the desktop app, which I've downloaded here, so it's a Windows or Mac app, and then you'd add the device. So I've already added it here, but to take a look at the device adding process, you would press the plus button in the top right, which will scan your local network for any KVMs. All makes sense so far. But in the top right, there's then this option for add manually. And if we click on that, you can see it allows me to add a device using a name, which is just an arbitrary name, whatever you want to call it, and the device's serial number. And this is a bit of a problem in my mind. So what I did as a test is I connected the KVM to my main network, and I then connected a laptop running this desktop app to my mobile phone's 5G hotspot, meaning that my laptop that had this desktop app was on a completely different internet connection, completely different network from the KVM itself. So with that, I was essentially simulating the KVM being on one internet connection and my device running this client on a completely different internet connection, which could be in completely different parts of the world. And using the serial number, which is printed just on a sticker on the bottom of the KVM, I was able to enter the serial number, press add, it found the KVM on the other internet connection and let me connect to it. Now, in fairness, when you press connect, it does pull up the login screen from the KVM, so you still need to know the password of the KVM to connect to it, but I really do not like that behaviour. Because what it means is by default, out of the box, this is making connections out to their cloud service, even if you haven't explicitly told it to. The cloud is kind of enabled by default. And then the fact that you can add it completely remotely purely by knowing the serial number is something I really don't like, because sure, the serial number, it is quite a long string of characters. It's not something I'm going to guess, but it is the sort of thing that you could very easily leak. For example, putting a picture of it on social media saying, oh, here's my new KVM, you've got a picture of the sticker on the bottom. You'll have possibly seen earlier in the video, I've just spent a painstaking amount of time trying to very badly blur out the serial number sticker on the bottom. Other situations I'm thinking, for example, if you're in, say, a co-location data center where lots of customers can walk through the data center and walk past your rack, if you had a KVM like this and you've connected it up, you've not had a long enough cable or whatever, so you've kind of left it dangling by the cable, and then it's maybe turned round and the serial number is visible from outside the rack, anyone walking past that could take that serial number and connect to your KVM. And sure, it does have that password prompt, but if you've got this on what you've thought was a completely secure management network, you might not have set a particularly secure password on it. It's just something I really don't like, and it's something very important to be mindful of. I'd really like to see GL.iNet change this, but really until they change this device, if I am using it, I'm going to be kind of completely firewalling off from the internet. I kind of see what GL.iNet was going for with this kind of setup process, since it means you don't need to make any connection to the local interface on this tool, you can just add it completely remotely, but I really don't like that behaviour. What I'd much rather see is a situation where you have to connect to the local web interface on this first and explicitly click a button to enable cloud connectivity, or if they want to make it so you don't have to access that web interface, at least do something like where you need to press the button a number of times to make the LED change colour to switch the cloud connectivity on. I don't like the idea that I'm buying something that straight away out the box is already talking to a cloud environment and could be added purely with its serial number. So hopefully this is something GL.iNet change in the future with future software updates, but I just wanted to make this part of the video now just so you're aware of this being the current behaviour at the time of making this video. And it's just something important to bear in mind, because if you're installing this in a sort of 24/7 environment connected to a server, I'd strongly recommend considering blocking this from being able to connect out to the internet in your firewall. So yeah, just wanted to jump in with this, but now back to the rest of the video. Now, while at first glance, this may look like they've built completely custom software like Jet KVM did, under the hood, it's actually based on PiKVM. GL.iNet have very much made their own front end for it and added in a few of their own features, but as you can see over here, if you open up the virtual keyboard, it's exactly the same as the one in PiKVM. Now, I'm sure some people have an issue with this, however they have released all their source code over on GitHub, as you can see here, and they've also added an issue tracker. In fact, in one of the issues where someone asked about adding more features from PiKVM into the GL.iNet interface, the developer actually pointed out you can just enable the PiKVM web UI by editing the Nginx config through the terminal on the device. And if you go over here, yep, it works. We have the PiKVM web interface running alongside the GL.iNet interface, just in a different port. So this does mean that if there's any PiKVM features that you want to use that GL.iNet haven't ported to their interface, or you just prefer the PiKVM UI, you can definitely do that. In particular, remember how earlier I mentioned that the PiKVM lets you pick a key map when pasting text into the connected device, but the Comet interface doesn't? Well, now you can do that in here. You can pick the key map and paste text. Although, if I'm completely honest, I think I actually do prefer the GL.iNet interface to the PiKVM one. It's just a little bit tidier compared to this. PiKVM is absolutely fine, but personally if I had to pick which one, I think I would actually use the GL.iNet interface. This also means that if you run into any issues or incompatibilities and you can't find support specifically related to the Comet, you can try looking up support around PiKVM and you may be able to figure out your issue. And we'll take a look at an example of this now. So the final test that I now like to put all KVM devices through is my so-called Fussy BIOS test. And in particular, it relates to machines that have BIOSes that don't like how some KVM devices present their keyboard and mouse inputs, where you'll be unable to use the keyboard and mouse to get into or to control the BIOS, and it only becomes active once an OS is booted. Now, I've not yet experienced this issue on regular consumer PC hardware, but I found it to be more of an issue on systems that have more complicated firmware such as enterprise servers, including a Dell PowerEdge R740, or more enterprise-focused workstations like this one here, where they've gone with slightly more complicated BIOS firmware. In particular, this machine is an HP Engage Flex. It's actually a point-of-sale computer that I got for stupidly cheap as a test device, but it turns out this also has BIOS firmware that really doesn't like many KVM devices, so let's try it out with the Comet. So as you can see here, I've already got it booted up into the BIOS, and as you can see if we press some keys, nope, none of the keyboard or mouse inputs work. So unfortunately, I can't use the Comet to control this sort of machine until it is booted into an OS, which isn't ideal. However, this issue is not unique to the Comet. This particular machine also has the exact same problem when using both the Jet KVM and the op interface, which is another really neat KVM device, except this time it works over a direct USB connection rather than over the network. But there is a solution. It seems as though the issue is because the KVM presents itself to the connected computer as a USB composite device that is simultaneously a keyboard, mouse and mass storage device. The firmware on these devices doesn't like that, potentially as a security measure, and therefore it doesn't accept any input from it. In fact, after my video on it, Jet KVM released a software update that contains a feature to allow you to change how it presents itself as a USB device. And using this, you can disable the mass storage so that it shows up purely as a keyboard and mouse. And this fixed my issue with the Jet KVM and allows it to work with such fussy machines, just without virtual media support. Unfortunately, however, this is not something that's available in the Comet's web interface. However, remember how I said it's based on PiKVM? Well, that's the solution. I couldn't find any information about this issue in relation to the Comet, but I was able to find how to disable the mass storage within the PiKVM config. All we need to do is go into the PiKVM, open up a terminal on it, which we can do through here, and then we need to edit the file at /etc kvmd and override.yaml, like that. And then we just need to add in this config down here. KVMD is the service we're configuring, MSD stands for mass storage device, and then we set the type to disabled. There's a ton of other config you can also put in here, it's all explained in the PiKVM documentation. So now we just need to save that file, like that, and run the command to reboot the device that's hidden behind the computer right now, so reboot the KVM, and then the changes should take effect. Okay, so now rebooted back into the web interface. One thing that's worth mentioning is that if you're changing all those config files and you mess something up and try and reboot, sometimes you'll get into a situation where the web interface then doesn't start. If that happens, don't panic because obviously you can't then get into the web terminal. The KVM is also listening on SSH, so you can SSH into it as the root user using the same admin password that you set to access the web interface and get in there and fix any config issues. You're not completely locked out, so I thought that was worth mentioning. But now we're booted back up again, we can come back into the same BIOS as before, and now we can control it. So everything now works there, absolutely fine, come through the web interface. Yep, all works completely fine. So that's fixed it. Although of course now virtual media is disabled, so if we go to virtual media up here up the top, you can see it still shows up, but none of the files that we already had shows up, and it shows no files, no sort of disk space used, and if we try and upload a file, it just won't do anything. So virtual media no longer works, but at least we can now come in here and control the BIOS on the connected computer. So yeah, unfortunately the Comet doesn't pass my Fussy BIOS test, but at least we have found a workaround, and hopefully in the future GL.iNet will add an option to the UI to make it really easy to disable and re-enable the USB mass storage device. So now finally, while I have this computer here, let's check it works with a VGA output. Because of course with most modern desktop PCs and things like that, you're going to have HDMI or at least DisplayPort, but with most sort of enterprise servers, you're generally still only going to have VGA ports. So let's check it works. So to use this, you're just going to need some sort of VGA to HDMI adapter. Just bear in mind with these that they are directional, so Most of the time when you look for adapters, you'll find HDMI to VGA. You need VGA to HDMI. It almost works the other way. And generally speaking, with adapters that are VGA to HDMI, they'll also have some way to power them because you need to power the adapter because VGA doesn't provide power. So let's plug it in the computer so we can plug USB in there. We'll plug the HDMI cable from the KVM into the adapter, then plug the VGA port into the back of the computer. And in theory, we should get video on the KVM. Give it a couple of seconds, there we go, and it works. So as you can see there, yep, this is working perfectly fine over VGA. So if you've got some sort of enterprise server or something like that that only has a VGA output, you can perfectly well use this, you just need an appropriate adapter. Now, I imagine some people will be complaining that it doesn't have VGA built in. I've seen a few people mention that on previous KVM videos I've put out. But ultimately, it just comes down to the sort of market that this sort of thing targets. Realistically, most people using this are going to be using a modern desktop PC type hardware that just has HDMI. If you've got some sort of enterprise server that has VGA, it probably already has some sort of built-in out-of-band management. And then it comes down to the sort of cost of the components. HDMI capture chips nowadays are a dime a dozen. They're such a common piece of hardware that they're super easy, super cheap to get and put in a device like this. As soon as you're starting to add in VGA as well, you're having to add additional hardware. That's going to increase the cost, more connectors, larger device. It just becomes a lot more awkward. And realistically, if you need VGA, carrying a VGA to HDMI adapter alongside it really isn't a big deal. And it works completely fine. And then next up, there's one more quite important configuration option that also seems to be missing from the UI, and that is the ability to set a static IP address. It just always uses DHCP with no way to change that. While this is fine for most sort of ad hoc uses, it makes it awkward if you want to have a bunch of these connected to servers, or where you want to use them on a network that doesn't have a DHCP server. Now, over on GitHub, GL.iNet have provided some terminal commands in response to a GitHub issue that will let you set a static IP address, so at least you can do that, but it would be nice to have that as an option through the GUI as well. Finally, while we're on the topic of IP addresses, one nice thing about this is when there isn't a DHCP server on the network, this device will self-assign itself an IP address, and the multicast DNS servers that enable the GL.KVM.local hostname to access the device will actually work with this. This means that you can just plug the KVM directly into a laptop with an Ethernet cable, wait for the DHCP client to time out, and the devices will self-assign their IP addresses, and then if we go to GL.KVM.local in the browser, the KVM will pop up. So that's really useful, and great for situations where you want to just use this like a portable monitor keyboard and mouse without messing with any sort of network configuration. So let's try it out. So we have the KVM sitting here, currently disconnected. I've noticed when it's not connected to the network, the light flashes, so I presume that's like a status thing. So we're going to plug it into the laptop, so plug that into the laptop Ethernet port there. If we pop up the network adapter settings in Windows, you'll see currently it's saying attempting to authenticate. You might be able to just make that out. Zoom in so you can see that. So we'll need to wait for that to sort of time out, fail to authenticate, fail to get an IP address, and then we should be able to use a KVM. So there we go, wait for that. It's now gone from attempting to authenticate to enabled. If we go into details, we'll see we've got a self-assigned IP address in the 169.254 subnet. And then if we come over to a browser, give it a little bit longer. It takes a little while for everything to start up at the KVM end, I think. So now I've waited for a little bit longer, I can now go to GL.KVM.local, like that. Go with that in the browser. Wait a second for everything to happen, and there we go. We're now getting a login page, so we can then simply log in here. And as you can see, we're now using the KVM as if it's a portable monitor keyboard and mouse. There's no real network connection here, no DHCP server, no IP addresses configured. I've literally plugged it into the laptop with an Ethernet cable, and it's all working. So that is super useful. So there you have it. That was a look at the brand new GL.iNet Comet KVM, and I'm pretty happy with it. It's definitely not perfect, but overall it works pretty well, and hopefully most of the issues I mentioned could be resolved with future software updates. Now, if I had to decide between this or the Jet KVM, it's a very close call. I feel that the Jet KVM is potentially a bit more polished from a software perspective, and the screen is a nice touch, especially if they updated it to allow you to configure the IP address from the touchscreen. But in day-to-day use, I'd probably still be more inclined to reach for the Comet just because of the full-size HDMI connector and separate power connection. It's just a bit easier to connect up without needing any sort of special cables. But realistically, they're both great options, so hopefully this video is helpful if you're trying to decide between them. So yeah, hope you found this video interesting or potentially useful if you're considering buying an IP KVM device. But all I have to say now is thank you very much for watching, and if you're interested in buying the GL.iNet Comet, then I'll leave links in the video description and in a pinned comment.